Yeah, cool. So hi, everyone. I'm not sure if you're seeing my screen. I'm not sure what the state is, but maybe I can just make the slides available. Unfortunately, there's going to be a demo, so I don't know. Just stop me and say if it's something is out of place. I'd like to talk a little bit about the usability in Theorem Improver, specifically targeting COC. And I'd like to start this talk with a question. Are the tools we use for writing proofs good? And what do I mean by good? So what is a good tool? So I have a reference from a very famous paper from Buscher-Nitzen and collaborators, which I'll leave in the references, and you can check it out after this talk. And they list three principles. One is applicability. Can you use your tool into real world problems? The other one is scalability and performance. That means, for example, when you start a small project, then your tool works fine, but can you also escalate that for larger size applications and continue to have a good performance with this tool? And the final point is usability, which is also very important. And I guess that's the core of HATRA. So let's discuss this bullet a little bit further. So according to the same authors in their studies, let me mention here, they mainly target programming language environments for mainly imperative languages like Java or Python. But they list three interesting principles which we should be able to reuse when we ask questions about tools for proof assistance. So one of them is like so when we talk about usability, your tool needs to be intuitive regardless of the user's experience level. That means a beginner should be able to use it, and a more senior person should also be able to use your tool without having too much trouble. The other thing that they mention is that when you have a good usability in your tool, that means it integrates well with a pre-designed workflow. So if you write proofs, you more or less know what you need to do to prove something, right? You maybe have a mental model in your head, maybe you need to do induction on some structures. You kind of know what you need to do, even though you might not know the tactics of a specific proof assistant, but you know the model, and that would be the pre-designed workflow. And then also a good tool in terms of usability supports refactoring. So those are the principles listed by these authors. And then, so in order to detect usability issues according to principles similar to the ones I just listed, then we do user studies. And then when we talk about the literature that we do have, we kind of have two axes of studies that we can do. One of them is kind of targeting qualitative research, and the other kind of targeting what do you get from large data sets. So when we talk about user interfaces for Theorem Improvers, so we do have multiple studies for different proof assistants, kind of targeting small groups of users, or we're doing some qualitative research. Let's say you have your classroom and then you do a study in your classroom. But when it comes from having large data sets of proofs, there isn't anything very active right now. I mean, of course, you can claim that you can get your proofs from GitHub. Let's say you can crawl GitHub and get all the COC files that you see on GitHub. However, you don't have the interactivity that you do have when you're writing your COC proof. This is not recorded. So the goal of this paper that I'm showing here is that how do I capture all these steps of interactivity into a large data set. So in order to do that, I'm using an online tool for writing proofs in COC, which is called JSCOC, which is right here. As you can see, if you've never seen JSCOC, here it is. And this is how it looks like. You can use JSCOC from the website or run it as a standalone application. You can just download it from GitHub and run it. And then I'm suggesting that we should have a specific modified version of JSCOC where we can collect the user interaction. So this is what I'm doing in this paper. I have a regular JSCOC instance, but I also wrap it into a Docker Compose, and then I can have other additional engineering tools interacting with it. So every time I have any of the events that I normally would have, into a Theorem Improver, like let's say any of these arrows, every time I click on them, I actually trigger an event to a Node.js server, and then I record this event into a Mongo database. And then this is how the generated data looks like. I have all the information about what was executed in which line, what was the tactic, what was the user trying to do. I also have a timestamp, and I also have some information about the user. So I have all these pieces of generated data. I also have information about the environment. I know what is the status of the worker running around it. I have information about the error messages and so on and so forth. So I have like the real snapshot of what is happening when somebody is trying to write a proof in Coq. And that generates an interesting data set. So this can be used for educational purposes, and that might be the most obvious application of this mechanism that collects data. But also it's related to Michael's talk. Maybe you can use that to suggest some automated guidance to the user. So this could help you to suggest tactics that you could be using in place of the code that you're writing. This could also help you to detect bugs, maybe into Coq itself or into the overall interface. So there are multiple applications that I can envision with a tool that collects the data set. Of course, this is a still very early version of what I have in mind. It's still a work in progress. There are many limitations here. Of course, you need to write the scripts to actually analyze the data. Since I'm collecting so much data, the final data set is going to be very large. And imagine you have, I don't know, a class of 300, 400 students, which is not unusual for North America, for example. Then you might end up with some issues, some engineering issues with MongoDB, for example, for excessively large data sets. There are some other engineering issues which I didn't tackle yet, since this project is in a very early stage. But I think the overall applicability of this might be very interesting if we combine that with other works trying to improve the way we teach people how to use proof assistants and the way we show people how to use them better. So I am really reaching out the time. So thanks for joining. And if you have questions, just post them on Discord. I'm going to be around if you want to discuss further steps of this project. Thanks.